Welcome to this lecture on the law of cosines. It's yet another particular relationship within a triangle, and that is again a triangle. It's called the law of cosine, and it relates all three sides to each of the angles one at a time. For example, a squared equals b squared plus c squared minus 2bc cosine a. That sure looks like the Pythagorean theorem, except that it's somewhat amended. The same law also applies as follows. So we can interchange these here, so we can say b squared equals a squared plus c squared minus 2ac cosine. Well, which angle? Well, the angle goes with the side that's in the very front, so cosine b. I can also say c squared equals, well, I guess b squared plus a squared minus 2ba, and then of course cosine c. Notice there are only three combinations possible. The proof for the law of cosines is relatively easy. I'm going to show it in just a moment. Let me just look at one here. C squared equals b squared plus a squared minus 2ba cosine c. So, for example, the side c squared equals b squared minus a squared. And imagine that you had a right angle here at C, which of course you don't. That would make the side A actually longer and the side C longer as well. So there has to be some kind of adjustment since they're not. It's not a right triangle, and that adjustment is this minus 2ba cosine C. In any case, here's the proof. Relatively easy. I'm going to go over to website. Here it is. Yep, here it is. So draw a triangle ABC, label the sides opposite each angle ABC. Make it so the horizontal base is the side labeled A, and mine in my lecture the baseline is labeled C, but really that doesn't matter. Draw an altitude or a height, so height H, and label that height C times sine B, which we know it's the opposite of this right triangle. Now that we took this very random triangle and we split it up into two right triangles. So here for the triangle on the right hand side, the opposite is of course C times sine B. The adjacent is this one here, would become C times cosine B as written down in the third diagram. And then this side over here is the total A subtract from that C cosine B, and that's what's written down here. At this point, we're looking at now the right triangle on the right-hand side, and we apply the Pythagorean theorem. So b squared equals C sine B squared plus A minus C cosine B squared. That's what's written down here. I'm not sure how good that looks up in eLive. Let me actually just try this here if I can increase the text size. Oh yeah, I can. There we go. I think that might look better. There we go. So b squared equals A minus C cosine B squared, and so on. Some algebra on this one here, and then on the right hand side what shows up, especially with this one here being a perfect square trinomial, comes up with C squared cosine squared B, which then is combined with the back one here, C squared sine B squared. And of course we can see that here we have a Pythagorean theorem. A cosine squared plus sine squared, of course, 1 times that c squared here makes the c squared survive. And here's that middle term from the perfect square trinomial, which then gives us the final result of where it says b squared equals a squared plus c squared minus 2ac cosine b, just the way we saw it in my lecture script. Okay, let's go back to that and do a couple of examples. And a couple of examples. When we look at these here, I'm going to pull these down and see which one we need. A couple of examples are that out of these 4 here, 3 of them would have to be given, and those 3 parameters, numbers that would have to be given, could be all 3 sides, A, B, and C, and then we calculate the angle. That's what we're going to do in the second example. It can also be of the entirety here, 2 sides are given and 1 angle. So for example, A and B are given, and of course B here, and the angle A is given, and we have to determine the angle C here. That particular way I just showed it actually would produce a quadratic equation, and they do it. They make it easy on us. So what they will do is they will give us sides B and C right there, and the angle A, so the angle that's in between the 2 sides, and we just calculate the A here on the other side by taking the square root. Okay, it says now as follows. Find the remaining parts for triangle ABC with A equals 60 degrees, B equals 20 inches, C equals 30 inches. So we're going to use this one here. There we go. Plug in numbers, and for that I believe I'm going to use the equation editor. Don't pay attention to the law of sines here. I just need that to get a start. So we're going to have A squared equals B squared. Well, that will be 20 squared plus C squared, which of course is 30 squared, minus 2 times 20 times 30 times cosine of the angle A, which is 60. Okay, and pretty much, of course, we're going to do just one algebra step of taking the square root on the right-hand side. Let me write these down here first. It's, of course, 400 plus the 900 right here, and that's going to be, let's see, 600 times 2 is 1200. 1200 times cosine 60, which we know is 1/2. And let's see, we're going to take the square root of the entire thing here. There we go. Get rid of the square over there. And on the side on my calculator, I'm going to calculate what we come up with. Let's see, that's actually 1300 minus 600 is 700. Take the square root. Respectively on my calculator, I'm going to do it in the very beginning. Square root of 700 is in the neighborhood of 26, I believe. So I'm going to do, let's see, square root of 20 squared plus 30 squared, everything in parentheses inside the square root, minus 2 times 20 times 30 times cosine 60. And if I hadn't made if I didn't make a mistake, yep, sure enough, 26.5 inches. And it looks like we have 2 significant figures, so it should be 26 inches, the answer. Okay. The second example that I have here is that 3 sides of a triangle is given, are given, and we're supposed to figure out what the angles are. In this case, it says find all the angles. Which one are we going to use? Well, it turns out we can use any one of these here, because we can find the angle A first, or we can find the angle B first, or we can find the angle C first. Let me take this one here. Okay. And I need to plug in numbers and then do the algebra. I'm going to scroll this down a little bit. So we're going to determine first the angle C. So let's see, we're going to have C is 18 squared, B is 20 squared, A is 34 squared, and then we have 2 times 20 times 34 times cosine, and this is what we don't know, cosine C. And then we do the algebra on this one. Again, I'm going to scroll down. So cosine C is going to come out to, I'm going to take this to the very front, equals, and I need a fraction bar, 18 squared minus 20 squared minus 34 squared, divide by negative 2 times 20 times 34. I'm going to do that on the side, so I'm going to come up with parentheses 18 squared minus 20 squared minus 34 squared, parentheses, divide by, parentheses, negative 2 times 20 times 34, 0.906, rounded. So therefore, C, of course, is the inverse cosine of 0.906. I'm going to see what I come up with that for that. Of course, what's good that we came up with a number smaller than 1, because otherwise we would have an impossible triangle. So I know for sure that it's something correct there. I come up with an angle of 25.05 degrees, but it looks like we only need two significant figures anyway. So 25 degrees. Now we still have to determine the angles A and B, but I still have to use one of the pipes of the law of cosines again to determine angle B, for example. So I'm going to do that right now. I'm going to actually copy these two here, and then it will be easier for angle A, because once we have the first two angles, then we just subtract those from 180 and we come up with the third angle. So here I'm going to determine angle B, cosine B. So in the front here, of course, we have, let me write this one down. So what I need next is B squared equals C squared plus A squared minus 2CA times cosine B. There we go. So here I plug in the numbers. B squared is 20. Oh, by the way, if I really was a little more up to it, a little bit lazier, I could actually use the law of sines at this point, because I already have an angle given in two sides. But we're in the law of cosines, so let's do that. Let's see. C is 18, and A is 34 again, and then we have 2 times 18 times 34 times cosine B. Notice that for the typical Pythagorean, you can't just switch these numbers around, 18 and 20 here, but we have different angles in the back, and that will make the relationship a true relationship. Okay, so here we're going to have the sum around 20 minus 18 minus 34, negative 2 times 1834, and here we have cosine B. And this time around I'm going to come up with, on my calculator on the side, 20 squared minus 18 squared minus 34 squared, divide by 2 times, negative 2 times 18 times 34. I come up with 0.882. And I'm going to determine inverse cosine of that number. to 28 degrees. And now, of course, angle A equals 180 degrees minus 25 degrees minus 28 degrees. And we're coming up with, let's see, 127 degrees for that one. And I compare that to the book, and my textbook actually had the same example, and that's exactly what they come up with. Okay, and with that one, I conclude the lecture on the law of cosines, and we're going to do a few problems.